All right, everybody, welcome back to DellyMaths Concepts. Today, what we're looking at is the 2024 curriculum-based solutions for mathematics. Here we go. If you have just found this channel, please like the channel right now, subscribe, and share this video as well, right? We're about to answer all these questions. So like the channel, share the video, and subscribe. All right, so let us go. All right. Question one says, which number has a 6 in the 100 place? So basically, this is the 6 that is in the hundreds place. So 9,687. This one is really easy. So that is the number that has 6 in the hundreds place. Let's take a look at number 2. Karen earned $8,000 per week. So this is Karen. Let us mark some important detail here. And Mark earns 10,000 per week. Which of the following shows the ratio of Karen's salary to Mark? Remember, K comes first. So basically, you want to line up your 8,000 because that's for Karen, and 10,000, that's for Mark. And what you want to do is to reduce them to their lowest form and then compare. So let us say we're taking off 3 zeros at the end to take off 3 here. I'm looking at 8 to 10. All right, so 8 to 10. Remember now, Karen comes first. The question says the ratio of Karen. So Karen comes first, so the answer is B. You don't want to make a mistake with B, right? Because remember, Karen came first. All right, so let's keep going. Examine the diagram below, then use it to answer item 3. What percentage of the diagram is shaded? All right, so first we want to count how many shaded parts, and then what's the total parts that we have there. So we have 1, 2, 3, 4, 5. So that's 5 out of, let's see how many in total. So that's 5 already, 6, 7, 8, 9, 10. So that's 5 out of 10, which is actually a half. And half of 100, we say this is 50%. All right, so here it is. 50% is shaded. All right. Let's keep going. Number 4. Examine the 10 marbles in the box below. An oval is drawn around a sum of the marbles. Use this to answer item 4. We're seeing that. What percentage of the total number of marbles is outside the oval? And so let us just quickly highlight the oval. If you don't see the oval, here is the oval. All right, so this is the oval right now. And those that are outside the oval, we have 1, 2 things that are outside the oval. So the question is, what percentage of the total? Context, total. So we have 2 out of a total of, let's count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 2 out of 10. And 2 out of 10, if you just times this by 100, you're going to get your 20%, right? So that is actually 20%. The answer is C, right? So we're referring to those that are outside the oval. 80% is inside, but outside is what we're focusing on. All right, let's keep going. The diagram below shows 2 bars. The bars represent the ratio of the number of pineapples. I want to pay attention to context. The number of pineapples to the number of mangoes, all right, at a fruit stand. Use this information to answer item 5. So we're seeing where this is pineapple and this is mango, all right. What is the ratio of the number of pineapples to the number of mangoes? Again, context, pineapple came first. So how many? We have 1, 2, 3, 4. We're looking at 4 in relation to 1, 2. So we have 4 to 2. This is for P and this is for M. So 4 to 2, you want to look, it's not there. Reduce it to its lowest form. We can divide through by 2, right? So 2 into 4 is 2 times. 2 into 2 is 1 time. So I'm looking for 2 to 1. 2 to 1 is B. Remember, you know, context. Pineapple came first, right? So 1 to 2 is there, but don't mix it up. Pineapple is 2 and mango is 1. Let's keep going. What is the result of 7. So this is actually 7/10 divided by 14 over 5. Now remember that we don't necessarily divide. We change our division to multiplication and we reciprocate the fraction that comes after that. So we're going to flip it. After we have flipped it, then we can do some quick canceling, right? If possible. And we can. 5 into itself is 1. 5 into 10 is 2. 7 into 7 is 1. 7 into 14 is 2. At the top, we have 1 times 1, which is 1. 2 times 2 is 4. So we're looking for 2/4. And there it is. I said 2/4. What I meant to say is 1/4. All right. So there it is. 1/4 is the answer. All right. Let's keep going. Let's keep going. Come on. The diagram below represents the 6 oranges that Jamie bought. Use the information, right, in the diagram to answer question 7. So we're seeing all those oranges. We have 6 oranges. Jamie ate 1/3 of the total. So context, Jamie ate 1/3 of the total of the oranges she bought. Which option represents the number of oranges left? So we're talking about 1/3 of 6 things. That's the amount that was ate. So you could work this out to find out how much was it and then use it to help you. All right. So for example, boom. All right. So we're getting 2. 2. So 2 was at 2 from 6 would leave you with 4. Okay. So 4 would have been C. This is the amount that's left, right? Or you could have found the answer by saying, all right, we at 1/3, that means 2/3 is left. So you could say 2/3 of 6, and it will take it to the answer. 3 into itself, 1. 3 into 6, 2. 2 times 2, it's going to tell you what's left. So there are diverse ways to do it, man. Or you could just cross off. You could put it in thirds. Look at this. You could put it in thirds and said, okay, we ate 1/3, and then we're left with 4, as in 2/3. So whichever way you want to look at it, you can come up with the answer in many ways. In the interest of time, we'll just work them out one way, all right? What is 30% of 60? Now, this can be done very simply. We're going to set up 30% of means to multiply by 60 over 1. Let us cancel the 0 after the 30, the 0 after the 10, and then 0 again with 0 up there. And we're looking at 3 times 6, and that is 18. And 18 is definitely here at C. So there you go. You should be doing well. I can see that many of you ace this. Examine the bar, right? And the information given about the bar below, right? So we're looking at this. All right. So let's read the context. Let's see what's going on here. It says the bar is divided into 15 equal parts. So which means that all of this is 15 pieces. All right. So that is something that we want to hear. That's 15. That's good. The bar represents 100% of a number. All right. So it's 15 pieces. That's 100% of a number. All right, no problem. The shaded part represents, the shaded part of the bar represents 20. Okay, so that's 20 out of the number. All right. 20 is 40%. All right. We are just told that 20 is 40%. Now, if they ask us for the original number, this is easy cheese. There are many ways to do it. I'm just going to do it one way. All right. Use the bar, the information to answer question 9. It says, which number represents 100% of the bar? 100%. That means we want to represent the 15 parts. There are diverse ways to do it, but I'm just going to say, if at all I'm given the percentage, which is 40% of a thing, right? So 40% is 20. You see, if you want to know the original thing, we said this a lot of times, reciprocate that. It becomes 100 over 40. Multiply this by the value that you got, which is 20. It's going to take it to the answer. 20 into itself, 1. 20 into 42. 2 into itself, 1. 2 into 150. The number is 50. Where is it? It should be there. It is right here at B. 50 is the answer to that question. So in other words, and if you find 40% of 50, you're going to realize that, hey, you get back your, you actually get back your 20, right? If you find 40% of that 50, right? All right, let's go. All right, number 10. Which option represents the ratio of the number of circles to the number of triangles? Context again. We put in circles to triangles. right? So, all right, so it's 3 to 2. So 3 is for circle, and I'm gonna put an O there, and then 2 is for triangles. So we wanna, all you gotta do is to break down these. Whichever of these can break down to give us a 3 to 2, we're good. 4 to 3 cannot be reduced, so that's not the answer. This is 4 to 6. Won't give me the 3 either. All right, D looks good. 6 to 4, 6 to 4. If I divide all of this by 2, I'll get 2 into 6 is 3, 2 into 4 is 2, and I'm seeing 3 to 2 as they ask us to represent 3 to 2. Circle, all right, to triangle. So D is the pick for number 10. Number 10 is D, all right? Let's keep rolling. Come on. Number 11. Which number, when inserted at X, it will result in it will result in the smallest product. All right, what we can do, there are multiple ways to do this, but what I could do with you is to show you. Let's multiply this. We're gonna get 3 6s, 18 over 5x, right? Now, which means 5 times x, right? So if you put a small number here, you'll get a bigger product, all right? You'll get a bigger result. So what I'm suggesting here is if you put the biggest number from the question here, it's gonna be divided by, for example, it's gonna be 18 over 45 because it's 9 I want to put there. So, and that is going to be a smaller number than if I'd put 2 there. Because that would have been 18 over 2 over 10, which is 1.8. This is a very small number. So 9 is what you want to put there, guys. 9. So if you put the bigger the number be at the denominator, is the smaller the result will be. We can keep that in mind. So 9 is the answer for that one without even doing too much, right? Let's go to question 12. Peter has 4 friends. The ratio of the number of red toy cars to the number of blue toy cars owned by his friends is shown in the table below. Use it to answer item 12. All right. So again, context, the ratio of the red, so the red here, all right, so the ratio of the red to the number of blue. So we are dealing with red to blue, and red to blue is what's going on here. So here's a question at 12. The ratio of Peter, right, number of red cars to the number of blue car is this. So Peter actually has 8 to 6. And you want to see which one of these match it, right? So which one of Peter's friend would have the same? I'm going to break this down. If we divide this by 2, we're going to get 4 to 3. So if I don't say that, I look for another thing. But 4 to 3 is there. I'm seeing Philip with that. So then D is the answer because Philip has 4 to 3. And 4 to 3 is the same as 8 to 6 in terms of proportionally speaking. Number 13. Julie added a number to 243. Her sum is less than 600, but it's more than 590. All right. Which of these numbers was added to? All you gotta do is to add them. So I'll say, let us say you add this and you want to see what the result is. Because you have a limit. It must be greater than this, and it must be less than 610. So you're looking for a number from 591, yeah? 591 all the way up to 609. So let me put what I want. I'm looking for a number when I'm done that would be from 591 to 609, right? 609. So we're looking for a number in that gap. So if I add this, say if I add 243, right? So I'm going to add it now. 243 plus 347. That's 590. So that's not more than 590. So this is wrong, right? So let us put, let's add 365. And the moment I see the right answer, I'm gone, you know. So 243 plus 365, right? I'm getting 608. So this gives me 608, and it is well within my range. And I only need one answer. That means only one of them will work. So I'm gone, right? So the answer is B. All right, let's keep pushing. Let's keep pushing. Let's see what's going on with this. Come on. Come on, let's see those who ace this. All right. So examine the set X, Y, and Z below. Use the information to answer item 14 and 15. All right. So let's look. We're looking at these. It says, which of the following describe set Y? All right, set Y. Describe set Y. What is set Y? I'm seeing 1, 2, 4, 8. Come on, 1, 2, 4, and 8. Those are factors of 8. So B is correct right here. Factors of 8. Right? So we're seeing that. Factors of 8, man. Things that can go into 8 without a remainder. Let's go for 15. Which of the following represent the set 1? So look at this now. We're representing 1, 2, there's a 3 added, there's a 4, and there's a 8. So when you look at this, I'm seeing where, okay, I'm seeing all of this, and I'm seeing it here again, except for 3, which you could see is right here. So now I'm going to unite. I'm going to unite X and Y. So it's a unity. So it's a union of X and Y. X and Y unite. Africa unite. X and Y. So X union Y is the answer. When you combine those members, you will get this, which is what they asked us for. All right, take a look at that again. X and Y, we're good to go. Number 16. The diagram below represents a pizza Fabian divided into 8 equal parts. The shaded parts represent the number of slices Fabian has left. So the shaded part is what is left. No problem. It's half of it anyway. It says use the information to answer item 16. Which of the following will result in the number of slices Fabian has left? Okay. All right, no problem. So how many slices Fabian has left? Let's count them. 1, 2, 3, 4. So in other words, then it's about how many slices in a 4. So in other words, which of these results could give me 4? This cannot give me 4. All right. This will not give me 4. This will give me 1 over 4. All right. So this is not it. This is gonna give me 16. All right. This is not it. I'm looking for 4. You know? All I'm looking for is 4. This is going to give me 1 over 16. That's not it either. So obviously this is the answer, but I could work it out for you. 1/2 times, and then I reciprocate this. 2 into itself 1, 2 into that 4. I was looking for 4 over 1, and definitely. But I wouldn't work it out in an exam, because if I eliminate 3 already, and they are really wrong, obviously the last answer is correct. So let's go to number 17. Jane and Sharon had medals in the ratio of 4 to 5. Jane has 12 medals. How many medals does Sharon have? Now, let's take a look. We're talking about Jane and Sharon. So you want to make sure that you associate the things properly. J is for Jane for me, and S is for Sharon. So it's Jane that has 4. The question went back and said Jane has 12. How did 4 turn into 12? You're going to think. I want you to think. 4 was multiplied by 3, turn into 12. That means I have to do the same proportion for this. All right, so 5 must be multiplied by 3 too, and we're going to end up with 15. So when Jane has 12, then Sharon is going to have 15. And they did ask for how much Sharon will have. Sharon is going to have 15, right? Because we multiply them both by 3. And I know that everybody got that. Let's keep kicking it. Examine the bars below and show information about them. Looking at question 18. So let's pay attention to the bar. So bar 1 says that number of left-handed students. All right, I'm seeing 2 students right there. Bar 2 is saying the number of right-handed students. 1, 2, 3, 4, 5, 6. So I'm seeing 2 here and I'm seeing 6 there. All right, no problem. Question went further. It says each bar is divided into equal parts. All right, we're seeing that. The bars represent the number of students in each class. We are seeing that. The ratio of, so we are seeing the ratio of left-handed to right-handed is 2 to 6. We suspected that. So it's 2 to 6, no problem. So everything is as clear. Here's the question now. What percent of the class is left-handed? How much percent in the class? 6 plus 2, 8. We have to be careful. 8 is in the class, right? So now 2, we're talking about left-handed, is 2 left-handed over, not over 6, 2 out of 8. And 2 out of 8, when you break this down, this is 1/4, right? So a quarter of 100. Come on, guys. Quarter of 100. We know it's 25%. And I know you got it. So those who, if you made a mistake and get 33%, I understand, but I'm sorry, all right? It has to be over the total because we're talking about everybody in the class, right? All right, let's keep going. the number line below is divided into 6 equal parts. You're seeing it. We could just color code it and go, look. Let's take a look. 1, 2, 3, yeah, 4, 5, 6 right here. So it's in 6 equal pieces, as you could see. Let's take it off. All right, let's go back to the question. It's in 6 equal pieces. The distance from home to store, all right, from home to store is 1 kilo, all right, no problem. K, we're talking about K now, right, is 1 kilo. And you say K, and it is saying that K rides 2/3 of the kilo. All right, no problem. To get to school. All right, from home, 2/3. All right. Now, use this information to answer. Which letter on the number line represent the location of the school? Look again. K rides 2/3 of 1 kilo to school. All right. All you're going to do is to say, all right, why not finding, there are multiple ways. Let's say we're finding 2/3. All right, hold on. 2/3. You're finding 2/3 of 6 pieces. Because they did say it's 6 pieces. All right. 6 pieces are here. So 2/3 of 6. Work it out. We're going to get 4. So I want to land on the 4th. 1, 2, 3, 4. That's 2/3. So it's at L. That's one way. Another way you could have done it is to split up this. Split it up. Split it up into thirds and then take 2 out of it. Look, thirds. 1/3. Thirds. 2/3 of the journey. Thirds. 3/3. Entire journey. So L is at 2/3. So whichever way you are comfortable breaking up this, go ahead and do it. It still works. Let's keep going. 4 students were asked to determine the value of 2 to the 4th. Come on, 2 to the 4th, 2 to the 4th. What does raising something to the power mean? It means the thing gets selfish. So it multiplies by itself. It doesn't care about anything else. So we're looking at 16. So 2 to the 4th. So let us see who is correct here. Nick is the correct person. Nick has it because everybody were doing something else. So here it is that Nick has it correctly. So Nick showed that it multiplied by itself 4 times. All right, let's go. Examine the statement Mike made below about comparing 2 decimal numbers using 21. All right, when comparing 2 decimals, the one with more digits after the decimal point has a larger value. All right, that's his claim. Let us disprove it, right? Compare each of the following pair of decimals. Which of the decimals would be a statement Mike made for that would make Mike false, right? So which one of these would have made Mike's statement false? Now, well, I'm seeing it at A already because we already know that 0.050 has more digits in the decimal than 0.50. This is a half. You know what this is? This is actually 5/100. Right? This is actually about 1/20. So this is like a very small thing compared to this. So you could see, look at it. The first digit after the point is a 0. The first digit after the point here is a 5. So obviously, this is telling Mark that your statement is not correct. A is showing you that, no, it's not about that. All right? It's about the digits, the value of the digits, rather than how many digits are after points. So let us keep going. Let's go. We're at 22. We're coming down. The 3 bars below shows how 240 was divided into 12 equal pieces. All right, shared among 3 boys, Tyrone, Andrew, and Michael. All right. Use this information on the bars to answer the question. All right. So I'm seeing here, I'm just gonna split this up. So you could see Tyrone got 3 bars, Andrew got 4 bars, and obviously now Michael got 5 bars. All right. Remember, there's a total of 12 bars we're dealing with. So you are seeing if you should add up these, definitely we're going to get over 12 bars. All right. Now, let us see if we can put the question now into context. Let us see what they want. It says, how much more money did Andrew receive than Tyrone? Now, let us find out first how the money part go, right? So we're going to divide up this 2,000. We're going to divide up this 2,000, 400, divide it up by 12. About $200 that. So 2,400 divided by 12. this is going to give you $200. That means each of these bars, I'm just going to drop it in to nice up the math. 200. Yeah? So you can check off easily. Yeah, we can check off this easily now. Yeah? Yeah, man. One of these is actually 200. All right. So you could see this man gets 600. This person gets 800. This person gets 1,000. So we can answer all the questions now, right? It says now, how much more? All right, so we're gonna have to subtract. How much more money did Andrew receive than Tyrone? Andrew than Tyrone. 800 for Andrew minus Tyrone 6. 200 more. So the answer for that is B. Let's go to 23. How much more did Michael receive? Oh, no, my wrong. How much money did Michael receive? Well, we did it already. Michael received $1,000 right there, and that's it. Moving on to 24. All right, guys, I see you smiling. I see a lot of people looking and laughing. Yes, man. That's how it's supposed to go. Which of the following is an example of the statement below? It says the product of a number and its reciprocal. So when you have a number, the product means to multiply. So you're going to flip the thing upside down and multiply it back by the original. So you're looking for something that is flipped upside down, and this is the only one that has a flipped. So you're talking about 4 over 3, and then it is multiplied by 3 over 4. Definitely we get 1 from that. We're seeing that is the product of a number and its reciprocal. B. 25. Anton made a statement which is shown below. Use it to answer question 25. Two fractions can be equivalent even though they are not represented in the same way. All right. For which pair of fraction model does the shaded part shows Antoine claims? In other words, whatever Antoine claimed, right? We're gonna look for that. In other words, we're looking for two fractions that are the same right now. For example, this is 1/4, and this is the answer. This is 2 out of 8. So if you break down 2 out of 8, you're still seeing 1/4. The moment I see it, and I'm not looking for two answers, I'm not looking for any more. The answer for 25 is A, because it is already showing what we're looking for. So obviously, the others will not show you what you're looking for. So we're gone. We're gone with the wind. All right. So let us look on 26. 26 says, examine the incomplete pattern. All right. Okay. What is the number that each term is increased by? So what I'll normally do is to pick on this spot. I'm not even going to think about it. I'm going to pick on 2 consecutive spots, and I'm going to subtract them. So we're talking about, just take your 26 minus the 19, and it's going to show up anything that is there. It is showing up that 7 is the difference. So the moment I'm seeing that, I'm done, right? So I'm picking on those 2 consecutive terms, and I find the difference between them, and it showed me what it was increased by. That means we don't need to fill out the spots anyway, because 7 is the answer. Let's keep going. Jada wants to calculate the price of the blouse below. It has an original price tag of 500. Use it to answer this. All right, original price tag is 500. All right, and we're seeing here in yellow here, we actually got a discount off. All right, we got a sales off, meaning the discount 20% will be coming off. All right, let us see what we want to do. Which of the following shows the correct way to calculate how much Jada would pay? All right, so in other words then, you're looking for how much she's going to pay when she get that special offer off. All right, so I like C, so I'm just going to nail C, because you see we're finding 20%, which is $100, and then you plan to subtract it from it. So the person will really pay 400, understand? And that's what we're talking about. Definitely, I will not even look at the others, because this is already correct, up and running. So C is for 27 is the answer. So let's keep going at it. Let's go to 28. We are at number 28 right now. 28 says Kelly, right? 28 says Kelly wants to share the remainder of the chocolate bar, right? Equally among her 3 friends. Oh, all right. So you could see that Kelly ate 1/3 of the chocolate. So you could see what Kelly ate, and we could see the remainder. All right, no problem. All right, no problem. This is good. All right, so Kelly wants to share the remainder of the chocolate bar equally among her friends. All right, she has 3 friends. This is very important. 3 friends. All right. Which diagram shows how much chocolate each of Kelly's? Okay. So if you have this, so here's the thing. This, will divide up back into 6 equal pieces. Sorry about my drawing. If you don't think it is equal, let me let it look a little better. Like there. So here it is a little bit better now. This is it. So in other words, then the remaining piece was divided up into 6 parts. Yes, man. So then one of the friend will actually get this size. So I'm looking for anything cut off here. So that's what one of the friend will get right now. We're talking about that. So this is the answer at B. All right, we're looking for it. See it here? One of the friend will get that because this is gonna divide up. Another one get this, yeah. And then another one got that. All right. So this is the answer. One of the friend will get that. Very good. All right, we're gone. We're gone. Number 29, right? It says examine the 2 fraction modes in modeled in the box below. Use them to answer 29. So this one is saying that we have 5, 6. All right, no problem. This one is a half. All right, what do you want me to do with it? It says, which of the following is true about the sum? No, this is about the sum of them. So let us add them up. We're not going to guess any one of these. When we get these things, we add them up. So you could add them up. There are multiple ways to do it. You can add them here because you're looking at it. It is already nicely done. So, all right, look, talking about 1, 2, 3, 4, 5, 6, 7, 8. All right. So that is 8. So this is actually 8 out of 6. That means if I added this, I'll get 8 out of 6 still. So I just wanted to, I want to do it, Let me do it and show you that. We get 8 over 6. So 5, 6 plus 1 half. Denominator, LCM 6. 6 into itself is 1. 1 times 6 is 5. So we have 5 plus 2 into the 6 is 3. 3, 1, 3. All right, good. So we get 8 over 6. When you add, all right, when you add the shaded, we got 8 over 6, right? No, let us look on what's going on. Let us look. Now, when you look at this, so you have to pay attention to details. Read it again to make sure. It says, examine the 2 fraction models below. All right, you're seeing them. All right, good. So we're talking about the sum. So the sum is 6, 8. Now, 6, 8, take a look at this. 6 into 8, 1 time, and 2 over 8. 2 over 8, 2 over, let me go again. 8 over 6 is 1 time and 2 over 6. So when you clear up this, you get 1 and 1/3. So we get 1 and 1/3. This is what it really is. All right, so it's 1 and 1/3. Now, which one of these is true? 1 and 1/3. Can't be this. Can't be this. It has to be over 1, but it must be less than 1.5. Because 1.5, is 1 and 4. 1/2 is 4 over 8 in this context. You understand? So this is between 1 and 1.5. It's on the lower end here, right here. So this is the answer. It's between that. Has to be between that. So we know it's more than 1, but we know it's going to be less than 1/2. And 1/3 is less than 1/2. Okay? So that's where it is. C is the answer for that. Let us keep going. It says here, examine the diagram below. It consists of triangle and a rectangle. All right. All right. What is the total area of the diagram? There are many ways you can do this, but I'm going to do it in context of what they have. So the area of the rectangle is going to be 6 times 10, and that is 60. The area of the triangle is base times height over 2. So that's 5 times 6 over 2. This is 30 over 2. This becomes 15. So 15 plus 60 is going to give me 75. My answer is B. So, I mean, you're just finding the pieces that you have, add them together. 75 is what you should have gotten there. Let's keep going. A school has 2 water tanks, right? Tank A and tank B. We're looking at the base. So the base of tank A is 300 times 300. The base of tank B is 230 times 350. All right. Now, the question says the height of both is the same. This is very crucial. So whichever one has the bigger base will win. You understand? In terms of have more capacity, is able to hold more water. So it says now, which statement is true about tank A and tank B. Now, it says tank A will hold more. Yes, I'm done. Tank A will hold more because it's going to have a bigger base because 300 times 300, that's 90,000. But 230 times 350, that's less than that. 230 times 350, that's 80,500. So because it has a smaller base and they both go up to the same height, the one with the bigger base will win. So in terms of having more. So tank A holds more. And I'm not going to read the other statements. You know why? There's only one answer to the question. The diagram below, not drawn to scale, shows a rectangular field with a section where we have a sandpit. All right, let me minimize this so we could see everything at once. All right, there you go. All right, what the question was? The question says, which of the following is the perimeter of the sandpit? Oh, perimeter of the sandpit. So we're going to have to apply ourselves a little bit, right? We want to find the distance along the boundary of the sandpit. Now, if you take a look, 25 stop right at top of the sandpit. 34 goes to the bottom of the sandpit. So we're gonna have to say 34 minus 25 here. And I think that's about 9, but I'm going to make sure that I don't make any mistake, right? So it's 34 minus 25, that's 9. So this length is 9 right here, which means that this is 9 over here as well, right? Yeah, man, it's 9 as well. All right, let's go again. For the other part now, 40. Over here is going to be 40, take out the 30, and it's going to give us 10. So this is 10, which means this is 10. So the perimeter is going to be 10 plus 9 plus 10 plus 9. This look like 18 plus 8, no, 19 plus 19 is 38. Yeah, so we're talking about 38. Look if we see a 38 for the answer. Yes, it is. So our answer is this. Remember, perimeter is the distance along the boundary. And remember, look what they said. Which is the following, or which of the following is the perimeter of the sandpit? So anybody pick 19, you have to pay attention to the question. We were told to think about the perimeter of the sandpit. So let me show you the sandpit. We are dealing with this. So our focus was this. That is our focus. All right. So we're not dealing with the field. And we're dealing with the sandpit. So we're talking about those measurements. So you would have gotten 38 for that. About 8 questions to go. Let's tie this up. The diagram below, not drawn to scale, shows a rectangular floor. All right. All right. So it measures 5 by 4.5. All right. One of these little bars is 0.25. All right. I see that. All right. All right. All right. All right. Good. All right. All right. So it says how many tiles? Okay. How many tiles? So this is a tile. So that's a square tile. Okay. There are multiple ways to do this. We can brush this off quickly. We brush this off 2 ways. I'm gonna brush it off 2 ways. What I could do is to find the area of this. So if I find the area of the floor, it's gonna be 5 times the 4.5, and we're gonna get about 22.5. All right. So when you work out your little math, you get 22.5. All right. So we get 22.5 for that. Hold on, let me blow up my diagram. Too big? All right. All right. So we get, so if I divide this by a quarter, now you do know that when you divide by a quarter, it means to multiply by 4. Divide by a quarter means to multiply by the reciprocal. So 22.5 times 4, that's 90. So we need 90. The answer is 90. Let's look at, yes, it's there. So this is the answer. However, let us say that you don't have that skill. What you can do is use your skill that you have. Think about it. One of these square bars, how many of them we got along the side? We'll get 1. So I could do it 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll get 9 of them along the side. And let's go down. We'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 along the side. So I'll get 9 of them going that way and 10 going that way. I could say 9 times 10, and it's going to take me to it again. 9 times 10 will take me to it again. 90 is it. All right. Not going to work it any other way. Let's go. All right. 34. Winding down. A cube-shaped cuboid cardboard box has a volume of, okay, So the volume is giving as 4,800. All right. The height of the box is 20. Okay. Okay. Which of the following could be the length and the width? All right, let me just drop the box. Let us see it now. Let us just drop the box. See box here, man. See box here. See box here now. This is our box. This is our box, right? This is our box. And we're talking about the entire volume. You know what the volume refers to? The space that it is taking up. And then the height is 20. Now remember the formula, you know? The area of this. Yeah? Times 20 gave us that. So if we divide this by 20, it's going to give us the area of the bottom. So 4,800, let's divide that by 20. It's going to tell us that the area of the bottom here was a result of 240. So that means if you say 240 times 20, you get the answer. Now, what you want to do is to see which one of these would have multiplied to give 240. So this is about 800. That can't work. This is about 1,200. This can't work. So anything, you know, anything that you see can't work. When you multiply this is about 120. 15 times 8, that's 120. Can't work. So it's 15 times 16. The answer is D. All right, so 15 by 16 will give 240, which is the bottom. So basically we're saying this part is 15, this part is 16, that is 20, and that is how you would have gotten it. So you have to look out and think in reverse at times. Let's go to question 35. Come on, winding down. The table below, not drawn to scale, shows a shape. And the explanation, two students gave about, two students gave about the perimeter. Okay, use this to answer. Okay, let us see what the student said. Student 1 says to find the perimeter of the shape, add all the length of the side along the boundary of the shape. I like this. Add all the length along the boundary. So this student is saying, hello, why not just relax, man? Relax and add this. This is what this student is saying. Relax yourself and add these. I like that. This is already correct right now. Student 1, I like what student 1 says. But let us take a look at what the other student had said. Let's go for it. All right, let's see what the other student said. Student 2 says, to find the perimeter of the shape, add up all the numbers shown. Add up all the numbers. This is what student 2 is saying. Add up this, and come back and add this. This is incorrect. All right. So this won't work. Student 2 is out of it. Perimeter does not go through the thing. So we're looking at student 1. Only student 1 is correct. That's it. Let's keep going. Let's go 36. Examine this shape below. The 6 things below. Which of the following, which solid can be created? Oh, it's the same solid we just drawn just now. It's a rectangular prism. Where is that? Rectangular prism A. Rectangular prism. Here it is again. Ta-da! You remember this? Yeah, man, we do this every week. Every week we talk about this in class. There it is. So if you break this up in parts and cut the edges and open it up, which we call the net is up there. There it is. All right. All right, let's go again. All right, the shape. So, all right. So S, T, and U make good floor tiles. All right, they fit together. Okay. All right. The shapes use a V and W do not. Okay. All right, we're seeing that. So these up here, they fit together. These, they don't make it because they're not fitting. They're leaving out some little space between them, and we don't want that to tile. All right. Now it says, which of the shape will not make good? Everything will be good except this. Everything will be good except this. All right. So this circle here will not work. This will not work. So D is the answer. That will not make a good one. Let's keep going. 38. Examine the mathematical statement below. Use it to answer question 38. 38 says, which of the following, all right, which of the following, when is replaced, the diamond would make the statement true? All right. Now, you're suggesting that, listen, if you add, so let us say we're looking at A. If you add, we'll get 14 here. Is 14 less than 2? No, so A is wrong. If we subtract, we'll get 2. Is 2 less than 2? No, so this is wrong. If we divide though, we'll get 1 point something. 1 point something less than 2. Yes, this is correct. I'm not even going to check the other one. C is the answer. All right. So we divide at 38. Let's go 39. 2 more questions to go. The table below shows the ages in years of the people in Susan's 18th birthday party. Use it to answer 39. So we're talking about a stem and leaf. So in terms of age, this person is 5, this person is 8, this person is 8, this person is 8. So this is 10. So this is 11. I mean, 11, 11, 11, 11, 12, 12, 12, 13, and it goes on. And then you have Susan, 18, right there. So everybody else is older than Susan, right? Everybody else now is older than Susan. How many persons in the party are older? This person is 28, this person is 30, 33, 36. 4 persons. There you go. All right, let's move it. All right, last question. We're going to use the graph to answer this. It says there are 40 grade 6 students in the class. Which student is true? Which statement is true? All right. More students have yellow bags than blue. Let's compare yellow and blue. More have yellow than blue, yellow than blue. Yellow is 7, blue is 7. That statement is wrong. We're looking for a statement that is true. So they are equal. More than half of the students have either black or gray. So let's add up black. That's 10. Gray, that's 8. So this is 18. Is 18 less? Is 18 more than no. So you're talking about 40. It's 20, so it's less than 20. So this is incorrect. White is the least. Let us look for the shortest bar. That's pink. Look, this is white and this is pink. Pink is the least. So this statement is wrong. Without doing the last one, this is the answer. If you want to do it to feel good, no problem. Quarter of the students have black bag. 10 would have black. Quarter of 40, so quarter times 40 will give you 10. So it is correct. You never need to check it. It's the last one though, and everything else was incorrect. So there it is. Let me know how many you get. Let me know how many you got. Okay.